Dr. T.V. Geeta, Professor, Department of Computer Science, College of Engineering, Guindy, Anna University. Her special interest, Artificial Intelligence and Natural Language. She has published more than 143 articles in national and international journals. She has guided around 7 PhD students. She has got Young Scientist Award from Government of Tamil Nadu in the year 2000, Chief Minister's Special Mention Award in the year 2002 and Woman of Excellence by Rotary Club in the year 2003.
Welcome to the UGC lecture series. In this lecture, we are going to talk about relational database and some guidelines for the design of a relational database. So, we are going to explain the informal guidelines, not the formal guidelines, and we are going to understand the role of null values in the design and in relational database in general. So, when you look at the database design process, it consists of a conceptual model and a logical model and an internal model. So, you have basically 3 models when you look at a relational database design process. So, these are the conceptual requirements of the application, that is what are the table designs and things like that. So, that is the conceptual design, and these are the application, the external model we talk about as the logical model, and then the internal model, exactly how we are going to store the database, what is the physical aspects of the storage design and so on. We will be looking into that also later. In this lecture, we are going to basically talk about the logical model. So, how do we decide on the goodness of a relational schema? That is the first question we have to answer when we talk about this. So, we have what is called a logical level. Logical level are to do with what are the relations and what the views. Views are actually virtual relations. And then we talk about the storage level. How do we store these relations as files? So, how do we decide that? We place one set of attributes in a table is better than placing them in another table. How do we know that? How do we decide this, and why do we do this? So, this is what we are going to answer in this class. First, let us look at what is a schema design. I hope you remember what we mean by a schema. A schema is nothing but the table and what are the attributes of the table and what the values of the attributes can be, what is the range of values. So, design the schema so that it is easy to explain the semantics. That is the first criterion we have. What is the semantics? What is the meaning associated with each of the attributes? And also, in addition to this, we want to minimize the storage space and we want to avoid storing redundant information, because if you have redundant information, automatically it means that we are using extra storage. At the same time, in certain cases redundant information may be necessary if you want to have speed of operation. We will come into those issues later, but as of now what we want to do is we want to make meaningful association between the attributes of a relational database, as well as we want to minimize the storage space and we want to minimize the amount of redundant information that we are storing. So, these are our design criteria. So, next we will talk about some informal design guidelines that we can use for when we are designing a relational schema. So, the informal measures of quality for a relational database design can be told in 4 steps. The semantics of the attributes must be maintained, or you must have the correct semantics. Obviously, otherwise the design itself is of no use. And as already we told, we have discussed, we have to reduce the redundant values in the tuples. That is, redundant values, if they are present across tables or in a table, we must as far as possible reduce this redundancy without affecting the performance as far as possible. You must reduce the number of null values that you have in tuples. So, you should not have an attribute for which the most of the values are null, then avoid that attribute, and you will have to get around a way of using that attribute even then. So, that is the reducing the null values, and this is very important. You should never allow, or you must disallow spurious tuples, that is tuples which are not valid or whose values or the tuples or the records which give wrong values. This is very important, you should disallow this. So, the 4 basic guidelines for relational schema design are: the semantics of the attribute should be correct, you must reduce redundant values as far as possible, you should reduce the null values in the tuples, and you should disallow spurious tuples. Let us first talk about semantics. You must not combine attributes from more than one entity relation type. You should not combine, that does not make the semantics clean. That is, you must not have, for example, an employee name and then suddenly you must not in an employee table, and then you must not say the address of the employee's employer the address of the employer should not come there. So, there should be a grouping of attributes associated with a single entity in a table. That is basically how you do the design. You should not mix up attributes of different entities, because then it does not make sense. So, that is the basics of the semantics. Of course, we also want to reduce the redundant values, and now we are bringing in another criterion. The design schema should be such that there should not be any anomalies. That is, there are different types of anomalies. We are now talking about update anomalies. Inside update anomalies, we have 3 types: insert anomaly, delete anomaly, and modify anomaly. We should not have any of these anomalies. So, when you talk about a design schema, you must ensure that you must check that these anomalies does not occur. So, with this basis, let us go into the guideline 1. So, the guideline 1 is this: informally, each tuple in a relation should represent one entity or relationship instance, that is, applies to individual relations and their attributes. So, what we are trying to say is, if you have an employee, then all details about the attributes of that employee, for example, his name, his social security number, his address, his salary, all that should come in a single table as far as possible. And you should not mix employee and student information in a single table, for example. So, this is about people. So, I have told employee. Similarly, student means student, his roll number, his register number, his date of birth, then his class, and those details should come in a single table. Okay, if you want to talk about his designation, designation alone you want to do a lot of manipulations on the designations, then you can talk about a company, what are the designations are available and who are working in each of the designations and so on. So, it depends a lot on what the application is, but still as far as possible keep one entity associated with one schema and one relation. So, attributes of different entities, for example, I have already discussed this: employees, departments, projects should not be mixed in the same relation. Now, here you have a tendency, let us take example of a employee database and or a database that deals with employees, departments and projects. You can have employee and then you have his social security number, his name, his address, and the department he is working in. Now, the department he is working in, how many people are working in that department, what is the, when was the department started, should not come in this schema. Similarly, if you have employee, his social security number, his name and so on, and then you also have the project he worked on. Okay, that can come here, but then that is relating to the schemas, but you should not have project, what are the nature of jobs in the project and who are the manager of the project, and such things should not come in the employee database. So, you get a point at, you decide this is my entity, or maybe there will be one attribute that links the two schemas, links employees and department. For example, which department the employee is working, but that can be considered as a information regarding the employee itself, is not it. So, that can be there, but other details about the department or the project should not come in the schema which you are associating with the employee. So, keep that as independent as possible. So, as I already told you, only foreign key should be used to refer to other entities. For example, here employee, which department he is working in, that is a foreign key which will be linking this employee schema to the department schema. Similarly, the project in which he is working will link the employee to the project schema. For that we use the foreign key. Similarly, what are the project associated with each department, or which project, I mean each department has how many projects, those two can be related through a foreign key associated in the department database or the project database, as the case may be. So, that is why what we mean by saying only foreign key should be used to refer to other entities. Okay. Now, in addition to entities, you can also have relationship schemas. So, as of now, what the examples all I told you, for example, employee, department, project are all entity schemas. We can also have relationship schemas, for example, works for. Now, this works for is a relationship schema connecting maybe employee and project. Okay. Now, inside that works for, you can say how many hours he works, what is the role he plays there, okay, and when did he join the project, and such things can be associated for works for. So, now you have a relationship between two entities, employees and project. with the relationship itself coming as a separate schema, the relationship schema. So, as far as possible entity, it depends on the application of course, whether you want a relation schema separately or you want to have the relationship coming and being answered by SQL queries, mixing of attributes, but that is a different issue. But if you have entities, keep them separate. If you have relationship, keep them separate. That is the basic informal guideline 1. So, a certain meaning is associated with the attributes. So, if you keep them to differently and separately, it is easier to explain the semantics and it is easier to update the, that is also important. We will come into those details later, but even for updation and all that, suppose the employees change, okay, then you just have to remove them from the employee database. So, the better will be the relational schema design. So, the easier to explain the semantics. So, basically again let us formally say what the guideline 1 is. Do not combine attributes from multiple entity types and relationship types into a single relation. So, have separate tables or separate relations for entities, separate relation, I mean for each entity and each relationship. So, design a schema that can be explained easily relation by relation. The semantics of the attribute should be easy to interpret. So, if you do it this way, if you design it this way, it will be very easy to interpret. When you are actually doing the design, it may take 1 or 2 iterations to actually come up with these independent, semantically independent schemas or relations. So, for example, you have employee, you have department locations, you have project, you have works on. So, all these are treated separately. Now, this SSN is this is a very well designed company schema, where you have SSN as the primary key, D number is a foreign key which matches with, I mean, or which links this relation with department relation. In department you have department name, department number and department manager. These 3 attributes or these 2 attributes should not come here as part of the employee database. So, that is what we are trying to say. Similarly, in department you have department location. Assume that one single department can be present in a number of locations, then the department numbers are linking department and department locations, but the locations are separate. Similarly, now you have here project. So, you have the project name, the project number, the project location and the department number associated with the project. So, that links these 2, and then you have works on. So, SSN and P number and the number of hours. So, each employee which project he works on and how many hours he works on. So, this if you look connects employee and project, these 2 entities, and this is a relationship schema. So, you have 3 entity schemas. This is a relationship schema which actually only talks about department, while this works on schema is a relationship schema which relates employee and project. So, this is the good design, where if you look here, this talks only about employee and also where the employees, which department the employee is working. This talks only about department, and in addition it talks about the manager SSN. This manager SSN also will come in employee. So, there is actually a foreign key, there are this D number relates this and this. So, this is a foreign key here. Here this is the foreign key which relates this department manager to the actual employee which is there in the employee entity. So, that is as far as the company schema. So, if you look here, there are some examples here. So, this is the employee, this is the department, this is the department locations. Here if you look for the same D number, okay, you have different locations. So, these 2 together is the primary key, because if you have only this as primary key, you have repeats here. And then here you have the manager number for each department name, and here you have many employees working in the same department. Okay. This is the one that we saw. This is the primary key, this is the foreign key, this is the primary key, foreign key. These 2 together are the primary key, but this is the foreign key. This is the primary key, this is the foreign key, and these 2 together are the foreign keys, and this is the primary key. So, these 2 together brings this relation to employee and project. This is the works on. So, look here, SSN, the same employee may work in 2 projects for different hours. So, that is what this is trying to show you, and this is a relationship, and this is the project. So, you have different project, this is the project name, this is the project number, the location and the department. You have 3 projects, X product Y, product X, Y, Z associated with department number 5, computerization and new benefits with 4, and so on. So, up to now we have looked at how to design the relational database and how to one of the guidelines. The first guideline was the semantics should be clear and neat, and that is why we say that the basic guideline for that is keep the entities separately, each entity separately and each relationship separately, choose the primary key properly, choose the foreign key to relate the two entities or two relations or whatever, I mean two relationships or whatever, and keep the schema, I mean semantics as separate as possible. That is guideline now 1. Now, let us take a short break before we go further. Welcome back after the break. Now, before the break we were talking about relational database design, and the first guideline we have already covered, which was talking about the semantics. Now, let us go to the other parts of the design. So, first we are going to talk about the next one, that is the redundant information. We had 4 semantics of the relations, and then we are going to talk about reducing redundant information as far as possible. That is another guideline that we use for the relational database design. So, now what does this mean? So, redundant information in tuples and update anomalies are connected together. So, let us look at that. So, information is all, if it is stored redundantly, there will be lot of wastage of space. Now, that is not the only criterion. Now, if there is only wastage of space, does not matter. If it increases the efficiency, it is okay, but there are some other problems that is associated with storing of redundant information, and that is it causes problems with update anomalies. So, you have 3 types of update anomalies, that is insertion anomalies, deletion anomalies and modification anomalies. All the 3 have to be avoided at all costs, and if you have redundant information, it leads to these 3 anomalies, which are in common called as update anomalies. So, with that in mind, let us go to guideline 2. Guideline 2 is to do with redundant information in tuples and resultant update anomalies. So, design a schema that does not suffer from insert, deletion and update anomalies, that is the guideline. If there are any anomalies present, if you cannot avoid, it is there, then note down, you have to note them down so that the application can take care of them when they are doing. So, this is an extra burden that you are putting on the application. Therefore, it is better to avoid these anomalies as far as possible. So, let us take an example of a update anomaly. So, let us consider the relation employee project, where you have employee number, project number, the employee name, the project name and the number of hours. Please note, here we have mixed 2 entities, employee and project, because this employee and employee name is to do with the entity employee, while project number, project name and number of hours is to do with the project. So, we are actually mixed the semantics of 2 relations, employee and project, but this is just to show you the example. Now, suppose we change the name of the project, okay, P1. Initially it was named as billing, now we have changed it to customer accounting, let us assume. Now, suppose we have 100 employees working in that particular project P1. So, we have here employee number, here you have project 1, here you have the project name, and you have 100 employees working on this project, which is quite possible on the project P1, whose name was initially billing. Now, we want to change it to customer accounting. Now, what will happen? You will have to change in all the 100 tuples associated with the 100 employees who are working on project P1. So, this is a typical update, or this is a modification anomaly of a type of update anomaly, where because of the wrong design, if you make an updation in one of the attributes which has nothing to do with that entity, I mean has to do with another entity, then suppose there, now here I have told an example of 100 employees. Now, suppose you had 1000 employees, then 1000 are tuples, you will have to change the project name, you have to go and change from billing to customer accounting, which is not a very efficient way of doing things. So, this is called as update anomaly. If you look at update anomaly comes in modification anomaly. Now, let us consider the same relation and then let us look at insert anomaly. Now, here this is very interesting. Now, if you cannot insert a project unless an employee is assigned to it. Now, what happens? You have employee number, project number, E name, P name, number of hours. Sometimes a company, it may so happen, gets a new project, okay, and it wants to recruit employees for that project. So, it does not have any employees associated. But now, in the middle of that, suppose a report has to be prepared with all the projects that are available with the company, then that information has to be available somewhere. Now, because we have mixed the two, what happens is you will have a project name. Now, if you want to put the project number and the project name, the employee has to be there. If there is no employee, the insertion cannot be done. This is a typical example of an insert anomaly. Also, the reason for this, as you can understand, is only because of the design mistake or the bad design. Now, let us just go back to the previous slides where we had a very good design, this example. Now, if you have project here, okay, adding the number of projects or changing the name will not affect anything. You get what I am trying to say. For example, suppose I have project here. Now, I am going to add a project product say A, and product A which is going to go to the first department, then I can put project A, I can put the project number whatever I want, where is the location and the department number, only one tuple has to be inserted, no problem. Okay. So, this is what we mean by insert anomaly. Same thing is true. Now, if an employee he is in the training place, and in software companies this is very common where people are put on bench, that means they are not allocated any project, but in anticipation of the project coming they are recruited and they are put on the bench. Now, in such a case the employee is not associated with the project. Now, if you have a database where the you have such a database, I mean relation in a database where employee has to be associated with the project, then you cannot insert an employee unless he or she is assigned to a project. Now, this is a problem. So, you cannot represent that bench strength that you have, because the design is again due to bad design. Now, again you have the delete anomaly. So, we have spoken about 3 types of anomaly. Update anomaly, we have 3 types as I already told you. So, here you have the same wrong design relation, and when a project is deleted, now suppose I want to delete a project. Now, the deletion of the project does not mean all the employees will be dismissed. Okay. It means that employees have to be reallocated to some other project. So, you do not want to change the employee database, you want to change the work for database, but since we do not have that here, when a project is deleted, it will result in deleting all the employees who work on that project. Or if the employee, this is one side, if the employee is the only employee associated with that project, he is the sole employee associated with that project, and if he leaves the company, okay, then what will happen? The project also will be deleted automatically. So, this is a deletion anomaly. So, again I will repeat, you have 3 types of anomaly: modification anomaly, insert anomaly and delete anomaly. Modification anomaly, what happens if you modify all the 100 employees, you remember, has to be modified, all the tuples associated with that have to be modified. Second, you have the insertion anomaly, where you cannot insert a project unless employees are allocated to it, or you can't have an employee with no project allocated to him. Similarly, delete anomaly, when a project is deleted, all the employees associated with that project also gets deleted according to this bad design, and or if the employee is the sole employee associated with that project, if this employee is deleted, all the project also gets automatically deleted. So, these are problems. Now, look here, employee department. Now, what happens? The employee is associated with the department. So, when the employee leaves and he is the only person in the department, department gets deleted. Here we are talking about update. So, if you have the name or the manager, for example, the manager of that department changes, which happens very often, name changes not so often, but the department manager can change every 6 months even, and every time the manager changes, okay, this changes, this value changes, then you have to change it in all the employees for which is associated with that particular department. So, here imagine you suppose the company has a policy that the managers are rotated among 10 departments every 6 months, and you have 10,000 employees distributed among these 10 departments, then every time all these 10,000 records have to be updated. So, this is a very big problem as far as these 2 designs, bad designs are concerned. These arrows I will be discussing in the next lecture. Then this is an example of the redundancy that occurs. So, if you have employee department, now you look here, this is the D number, okay. This is that foreign key association. Now, if you have 2 employees working for 2 departments, this information is actually redundant, because already here you have that information, again you have the information again. Similarly, this is redundant, this is redundant, this is redundant. So, that is why we say this is a redundancy. If you take this employee project, the employee name is redundant as far as the project is concerned, and as far as the employee is concerned, the project name and the project location are redundant information. So, this type of bad design also results in not only the anomalies, it all because of the redundancy the anomalies come into the picture. So, you have redundancy as well as update anomalies, commonly called update anomalies, modification anomaly, insertion anomaly and deletion anomaly. If insert a new employee into employee department and no department yet, what will happen? That is again this is just if you create a new department with no employee, what will happen? This is similar to what we saw for project. If you add an employee in the department, what happens? If you delete the last employee of a department, what happens? And if change the values of a particular department, we have discussed these issues. So, both the schemas that we have discussed suffer from update anomalies. We will come into these what this arrows mean later. The third guideline is to do with null values in tuples. Relations should be so designed such that the tuples have the least number of null values as possible. It is not impossible, it is not possible to actually have no null values, sometimes that is not possible, but minimum null values you should have. So, attributes that are null frequently could be separated out into separate relations with a primary key. So, what are the reasons for nulls to happen? Attribute are not applicable or it is invalid. Attribute value is unknown, but it may exist. Value known to exist, but unavailable due to some reasons. How to account for nulls when aggregate operations? This is a problem with having nulls. So, if you are having count or sum or average or such things, how do you account for null? So, as we told, nulls can have multiple interpretation, not applying to the tuples, unknown values, unknown but absent values. So, the guideline 3 is to do with this. Avoid placing attributes with null in a base relation. If nulls are unavoidable, make sure they apply only to exceptional cases. So, as far as possible. If you use null values, it can mean different things. If many attributes and lots of nulls, it means wastage of space obviously, and as I already described, aggregate functions have a problem. So, avoid that. There is no, I mean sometimes you cannot avoid, but as far as possible you avoid. Next is spurious tuples, that is the fourth, this is to do with the fourth guideline. Bad designs for a relation database may result in, this is very much of a problem because it may result in wrong results itself, erroneous results for certain join operation. So, this is what we call as the lossless join property, so that you have meaningful results for join operations. We will discuss this lossless join property later on in detail, but basically you should avoid spurious tuples, the generation of spurious tuples during a join operation. So, the guideline 4 says the relation should be designed to satisfy the lossless join condition and no spurious tuple should be generated by doing natural join on any of the relation. So, relation schemas can be joined with the equality conditions on attributes that are either primary keys or foreign keys in a way such that no spurious tuples are generated. So, there are two important properties of decomposition: non-additive or losslessness of the corresponding join and preservation of the functional dependency. We have not discussed what a functional dependency is, but basically this is a guideline just to avoid the spurious tuples. We will go into this later. So, property A is extremely important and cannot be satisfied, that is losslessness. Property B is less stringent and it can be sacrificed. So, this is an example again, employee locations, employee projects, and you see here that the employee project you have redundant information, and this is a natural join. If you take these two, this is employee joins with employee project 1, employee project 1 with employee locations. You see that when you do a join here, you have these, you will have lot of spurious tuples. Now, why do you get this spurious tuples? You are joining employee project 1, that is this one with this, okay, and then you are joining with this and so on. So, you have, that is the thing. So, this is a spurious tuple. So, these type of spurious tuples have to be, and it can result in a large number of such spurious tuples which you have to disallow at all costs. So, lossless join will guarantee that there is no spurious tuples, and so you have to design with an equi-join. We will come to this in detail later, with an equi-join with the primary key and a foreign key. So, design schema, so no anomalies occur, but what about performance? So, must always do join when you want to answer a query. So, it is best to specify joins as views so that anomalies can be avoided. So, this is by the two different relations. So, this is again employee locations and project locations. You see the presence of some spurious values, and This is the applying the natural learn. This is where we saw the spurious coming into the picture. So, here basically we explain the informal guidelines of relational database design and we explain the role of null values. The exercises, you just take the 4 informal guidelines and then take another example or an application of your choice. Maybe we can take a student database and try to design a relational database for student along with the fees he pays. Student information regarding marks and all that, and along with his fees connecting him with the registration for that particular semester. And with that example you can explain what is insertion, deletion and update anomalies. Thank you.